Today's video, we're going to be talking about converting fractions to decimals by hand. If you have a calculator, your calculator can do this for you, and that's really a cool tool to use, but to show you where it comes from, and it might be useful to be able to do it by hand. If you don't have a calculator, or maybe you have a test or a quiz that is no calculator, part of the SAT is no calculator, and the ACT. So just be aware of that. So we're going to use some long division to do this. What we're going to do is take the denominator, and then we're going to divide that into the numerator. So this is going to look like this. 7 on the outside of the box or the house or whatever your teacher called it when you first learned it. And then 2 on the inside. Make the house a little bit longer than you normally would. Because you think, well, 7 doesn't go into 2. It does, but not completely. So you're right. So I'm going to put a point. Here's my decimal, and I'm going to put 1, 2, 3, 4. I'll do 4. I'm going to do 4 of these. 4 zeros. You can do as many zeros as you want, really. But 4 should be plenty for what we're trying to do today. The first thing I'm going to do is I'm going to bring this point up here just to remind myself this is a decimal. And it should be, because 2 over 7, it's not a whole anything. It's point something. So I'm going to treat this like it's a 20. So 7 goes into 20 how many times? 2. And then this is just a long division review for you here. So that's 14. 2 times 7. We're going to subtract them. So I'm going to go through this kind of quickly. 6. Bring down the 0. And then we have 8, because that's 56. If you want a review on long division or would like a video on that separately, let us know. We've got 7 times 40, or 7 goes into 40, excuse me. We got 5 times 35, subtracting 5, bring down your 0. 50, let's see, 7, because that's 49. And 1, and essentially you can keep this going for a long time. So we're going to round these. So for this video, we're going to round to the thousandths. Thousandths. Thousandths? Sure. So that's 3 decimal places. So I need 4 decimal places, so I know if I'm going to round up or if I'm going to keep it the same. So here, I'm going to go ahead and say, here, let me do 2 over 7. And because I cut my decimal off, I'm going to make an approximation. Say it is approximately 0.286, because I took my 7 and I rounded my 5 up to a 6 because 7 is bigger than 5. Some rounding review for you there. Alright, so that's if it keeps going. Some of them will cut off. The 7 over 8 is going to cut off, so I'm going to do that one right here. A little bit of space. Same thing. Denominator on the outside, numerator on the inside. 1, 2, 3, 4 zeros. So we're going to do the same thing. So I'm going to have an 8, because 8 times 8, 64, subtracted from 70 leaves me with 6. Bring down your 0. I've got 7. And then 56, subtracting. I get a 4, bring down this 0. And then 5, and then 8 times 5, 40, 0. My remainder is gone. So I actually didn't need this 0. So I can go ahead and erase it if I want, or keep it. Because essentially this would just be zeros forever, and I don't need to write that. So 7 over 8 equals, and I don't have to use the squiggly ones because it does equal, it stops, 0.875. There you go. So that is how you convert decimals to fractions using the long division. Again, use a calculator to check it, if you want, because some of them might go on forever. Convert these fractions to decimals, round to the thousandths place if needed. Go ahead and pause and try these. Do them by hand. Some of them you'll need to cut off, some of them you won't. So pause it, try it, and I'm going to do them now. So again, I'm going to do it by hand. I'm going to pretend I don't have a calculator on me. And then in the end, I'm going to check to make sure that they're right, which I've already done. Again, 4 zeros to start, just to be on the safe side, because it says thousandths. I might not need all the zeros, so that's okay. 4 goes into 37 times, 28, 2, 0, and that's 5, 20, not 10. So that would be 0.75. I would memorize that one. I'm going to have a list that I suggest you should memorize on, I think, the next slide. So 3 over 4 is 0.75. Think 3 out of 4 quarters is 75 cents. There you go. 9 over 3, we're going to have, or 13, excuse me, we're going to have a remainder here, or a longer decimal here. 9.0000. All right, so I have point here, put a 6. You might have to play around with this one because it's a little different. I can't say I have all of my 13s memorized, and that's okay. So 6 times 3, 18, so 6 is going to be 78. Subtracting, I get a 12. Bringing down my 0, let's see, 9. Let's try 9. I get a 7 and an 11, yep. And I get a 3, bring down a 0. It's not going to be much, that's a 2. And then I have, that's going to be 26. I do know that one. And then a 4, whew, bring down your 0. You're going to keep bringing just down zeros when you do these. It's a lot. All right, and let's see, that's going to be about 3 or so. Could that be 39? Yeah, and this one might go on for a long time. So we're going to cut it off there and say that 9 over 13 is approximately, because I cut it off, 0.692. Okay, and again, it's a 2 because of the 3. The 3 is not big enough to round my 2 up. All right, and then your last one here, 5 over 3. I'm going to do this over here for space. Ooh. All right, so I have 3 divided by 5. So notice, I still always put the denominator on the outside, even if it's smaller. That's okay. Go ahead and get me some zeros up here. So I have 3 goes into 5 one time. Cool, that's sweet. I know what that's like. So then I have 2, bring down the 0. I am going to still bring my decimal point up. So that one always just goes right where it is. 3 goes into 20, let's see, 6 times. And then I've got 18, so then I got 2, bring down your 0, there's 20 again, then I've got 6. And do you see what's happening? Oh no, I'm stuck in a loop. That's okay. This is a repeating fraction, so essentially this is just going to be 1.6 repeating. So we're going to go ahead over here and say that 5 over 3, let me put an arrow, equals 1.6 repeating, because you're going to get trapped into that 20 minus 18 is 2. Bring down a 0. It's 20 minus 18 is 2. It's going to go on forever. So that's called a repeating decimal. If you haven't worked with those before or seen those, it's just the same number goes over and over again forever and ever. And that's okay. They happen a lot with the 3s. So converting a decimal to fractions using your calculator, just type it in using the division sign. Some of them have the actual division symbol. Some of them have the slash. The slash. Slash. Okay? So it's dividing is what that is. So you're essentially dividing 2 divided by 7, and it's going to pop up with whatever the full decimal is. If it stops, your calculator will cut it off. If it keeps going, your calculator will cut it off based on the size of the screen. So there's that. Some calculators are able to convert fractions and decimals back and forth. Just depends on what calculator you have. The TI-84 and 3s and 9s and all of those are really good with converting those. Useful. Make sure you can do it by hand as well. Good for checking it. Here's the ones I suggest you memorize from fractions to decimals. A half is 0.5. Because these come up a lot and it's like a waste of time if you've got to go in by hand or even on your calculator. I'd say no, a half, a fourth is 0.25, 3/4 is 0.75, 2/4 is a half. That's why I'm not going to write it. I'd do the fifths. 1 over 5th is 0.2, 2 over 5 is 0.4, 3 over 5, 0.6. So what do you think 4 over 5 is? That's right, it's 0.8. Good job. The 1 over 6s, oh, I skipped the 3s, I'm sorry. 1 over 3 is 0.3 repeating. 2 over 3 is 0.6 repeating. 3 over 3 is 1. So these are the ones I suggest that you memorize just because they pop up a lot. And anything over 10, of course, 1 over 10. This is 0.1, 7 over 10, 0.7, right? All right, and then comparing fractions, which is a big thing you'll do, especially if you're trying to see what's what. It's easier to compare fractions when you know the decimal equivalent. So like 1/4 is 0.25, and then 2 over 3 is 0.6 repeating, so you know that 0.6 repeating is bigger than 0.25. Let's see. I'll go across. 2 over 5 is 0.4. 6 over 15 you can simplify to, let's see, they both have a 3 in it, so divide the top by 3, and then you've got 3. I'm sorry, divide the top by 3, you get 2. Divide the bottom by 3, you get 5. Oh, that's the same thing. Those are equal. 0.5 for your half. And then 3 over 7, you can divide that. And you're just trying to see where it falls with a half, so you may not have to do all 4 zeros. So let's see, 7 goes into 30, 0.4 times, it's going to keep going. So I know it's going to be 0.4 something, so I know that 0.5 is bigger. So I don't actually have to solve the whole thing, which is pretty nice. And then 0.8, I'm just pulling these from my chart from the last page, is 4 over 5. 9 over 8, kind of a trick with these, I guess you could memorize them. Anything over 9 is just whatever it is repeated. So 8 over 9 is 0.888888888 forever. So, and that's actually bigger than just 0.8, because this would be 0.80 and this would be like 0.88. So it's like 80 cents versus 88 cents. 88 cents is more. So that is your comparing fractions. Yeah, make them decimals, sorry. Easier to make them decimals to see, and some of those are easier just to memorize. That way you don't have to go through dividing by hand, especially if you don't have a calculator, if you're not allowed to use one. All right, that's it for this video. Hope you guys have a great day. Bye.